So, good morning, everyone. My name is Arte Gische. I am Deputy Secretary from the European Water Association, and welcome to today's webinar, Water Reuse Challenge and Opportunities in Europe. We'll start now. We are really glad that you are with us, and we would like to mention before starting that this event is a kickoff event of IFAT Munich. It's actually happening in 4 weeks, so we are really excited about it. So IFAT is the world's leading trade fair for water, sewage, waste, and raw materials management, and it's taking place between May 13th and 17th in Munich. If you would like to register and to get a free ticket, you can use a QR code that's there. And this webinar is part of the European Water Association activities happening there. You will see all information in a presentation that you will get after today's event. So you can make sure, and using this ticket, and make sure to secure a free ticket for joining the EW activities on Monday 13th at 2:30 on a booth stage where we'll have another discussion about water reuse, chance or meander. Yeah. So short talk about the European Water Association before we start. We are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries, either national members, corporate members, and research members. We aim to provide a forum for the discussion of key technical and policies issues in Europe, either through conferences, workshop meetings, working groups that we have, and through our publication on social networks and directly on our website. And today's event is taking place under one of those umbrellas to reach and discuss to everyone about water reuse. So just a couple of questions before we dive in directly. Some more information about today's, please use the chat box and or the Q&A box below it to ask you questions. And please note that all PowerPoints will be shared with you after today's event, and there will be a recording available on the European Water Association YouTube channel. Yes. So I will start now, and the first speaker will be Roberta Maffetone, Scientific Project Officer from the European Commission Joint Research Center, and her presentation is titled is State of the Art of the EU Water Reuse Regulation. Roberta holds a PhD in environmental engineering, and she has expertise in the field of wastewater treatment and is a driving force behind the European Union initiative to encourage water reuse. As a scientific project officer at the European Commission Joint Research Center, she plays a pivotal role in facilitating the implementation of the regulation on water reuse. We are really glad to have you with us today, Roberta. Please, the floor is yours. You have 25 minutes.
Good morning to everybody, and thank you, Arthur, for the presentation, and thanks for the invitation to present this very interesting webinar. I will start to share my presentation now. So today I will present about the state of the art of the European Union water reuse regulation. First of all, I would like to introduce the Joint Research Centers, which is the Commission Science and Knowledge Service, and provides scientific evidence throughout the European Union policy cycle. My unit is the D2, the Ocean and Water, and within my team, the Water Lab team, we supports policy development on several topics regarding water and wastewater, and the specific I support the policy on water use. So why water use is became a strategy for the in the European Union to increase resilience of water. This is mainly due to the an increasing of water scarcity in part of the territory of the European Union, especially in the southern region, which affect overall 38% of the population and 29% of the territory. Also, climate change had brought to more recent droughts events that have expanded not only to the southern region of the European Union, but also to central, eastern, and in some part of the northern Europe. The sector that is mostly affected by droughts is agriculture, that accounts of 50% of the total losses that are due to these events. At the same time, agriculture is also the sector that is consuming most of the water that is abstracted from freshwater sources. So in 2017, it was accounted that agriculture, forestry, and fishing accounted for almost 60% of water consumption. Agriculture is also the second sector for freshwater abstraction, which include abstraction from groundwater and surface water. Because of these conditions, then the European Union set up several strategies and actions to promote water use as a solution to preserve freshwater resources and then increase resilience to water stress. Those are some of the strategies where water use fall in. We had a blueprint to communicate European Commission communication on blueprint to safeguard Europe water resources. Then water use falls into the circular economy action plan and the broader um, action of the European Green Deal, and also within the zero pollution action plan. Within the water acquis, there are other legislations that they are supporting the use of reclaim water. Here there are two main important, and they are currently under revision and very soon to be approved in their final form. Is the Urban Wastewater Treatment Directive and the Industrial Emission Directive. So the Urban Wastewater Treatment Directive in the new proposal encourage the reuse of reclaimed water, not only in agriculture irrigation, but other uses, by also providing requirements to better monitor, track, and reduce pollutions in wastewater. The reuse, the potential of reuse should be assessed within every territory of the member states, considering risk-driven basin management plans and also integrating the in urban wastewater management plan. It's requiring now the application of quaternary treatment, which means a treatment for the removal of micropollutants whenever appropriate, when water is considered to be reused in agriculture irrigation, but also in other uses, and also provided the regulation of applying tertiary treatment, which means removal of nutrients in case the water was reused in agriculture. The Industrial Emission Directive also promotes water use within the industrial settings, and in particular with incentives in the more efficient use of water, which indeed will include also the recycling of the water within an industrial process. So the water use regulation 2741 of 2020 entered into force indeed in 2020, but its rules starting applying on 26 June of 2023. It applies to effluent that comes from urban wastewater treatment plants and regulate the use of reclaimed water for agriculture irrigation. It sets out minimum requirements for water quality and monitoring, risk management provisions, a set of permits and also transparency for the communication to the public. The Annex 1 of the regulation defines minimum requirements for agriculture irrigation for 4 quality classes from A, B, C, D, from the highest quality to the lowest. The water quality classes is selected on crop category. So whether the crop that is irrigated is intended to be eaten raw and unprocessed, or and they will be in direct contact with the water, and thus combined with the irrigation method that will determine if the crops will be in contact with reclaimed water. Minimum water quality requirements are established for E. coli, BOD, TSS, and turbidity, and also Legionella and intestinal nematodes in certain cases. The regulation also sets minimum routine monitoring requirements and validation monitoring requirements that only applies to new facilities or upgrade for Class A. Um, um, the regulation also requires the drafting of a risk management plan for water reuse system. This plan should be based on the 11 elements that they are reported in the Annex 2 of the regulation. A risk management plan is a process that aims to identify any hazards and assess any risks to human and animal health and the environment within the water use system, identify preventive measures that there could be any treatment barriers and actions that will reduce and manage the risk. And control this through procedures and protocols of monitoring and control. And also it will set out the outcomes of the risk management plan, could set out additional requirements to water quality and monitoring to those that they are established in the Annex 1 under minimum requirements. So the Joint Research Center provided scientific support to the water use policies throughout the whole cycle. Here there are some of the publications that they have a focus on water reuse. There are science and policy reports and technical reports. The last two that I highlight in red are one, the scientific base on the minimum quality requirements that has been included in the water use regulation, and the last one is a technical guidance on risk management for agriculture irrigation schemes in Europe. There are, of course, the scientific support is keep going, and there will be more publications to come on this topic. So as I said, the scientific support to water use policies have been continuous during the whole cycle. As JRC, we organize technical workshops, and we are currently organized on water use. First, a series of workshops focus on developing guidelines for risk management plan, and now we are continuing to investigate uses beyond agriculture irrigation, but also to support the implementation of this regulation, in particular regarding the development of the risk management plan and some challenges that we are observing. We participated to the European Commission Working Group on Water Use, and we supported the drafting of the technical parts of legal documents. What is the status then of the water use regulation in Europe? Here you see the map that's been reported on the WISE freshwater website. This map is not yet updated, but it shows where water use was allowed in the member states as of June 2023, so when the rules of the regulation started applying. This map will be updated, and considering the notification from the member states on whether they will apply, they will invoke the Article 2, which means they will decide not to practice water use in a whole or part of their territory. because of several reasons, maybe to maintain the ecological status of rivers, or because the territory does not need water use due to the abundance of freshwater resources and the low irrigation demand. This map, it's under development with already some of the information sent by the member states, so it will be updated soon. Mm, the Commission support the implementation of the regulation is specified here. Mainly, the first document supporting the implementation is the guidelines on the application, which included also guidelines on risk management plan published in August 2022. The very recent delegated regulation on technical specification of risk management, which is now adopted, is not yet in force, is under 2 months scrutiny period with the European Parliament and the Council, and we expect that will enter into force on 13 of May 2024. This delegated regulation has been draft in collaboration with the JRC and the working group on water use and the member states, and also collected comments from the public on the Have Your Say portal. Another support to the implementation of the regulation is the definition of the data reporting format on the data on water use that member state will need to report. And this is a work that is done mainly by the European Environmental Agency. Digging into the risk management plan, say the delegated act defines the technical specification of the 11 elements of risk management plan that they are indicated here on the right. It's been developed according to the JRC guidelines, and it details all the specifications for the elements, from the system description to identify risks to set up preventive measures and protocols for risk management. The risk management plan, they extends from the entry point of the urban wastewater treatment plant to the final use in agricultural field. Here is a schematic where you could see from where all the components of the water reuse system that could be, when appropriate, when relevant, included in the risk management plan. And the risks should be assessed for hazards, which are pathogens, pollutants, or substances in reclaimed water, and hazards events, and for several populations at risk and environments at risk. Here is a schematic that I just wanted to share to have an idea how hazards or pathogens and pollutants in reclaimed water could be screened in the reclaimed water for risk management plan, considering the applicable legislation that they are required within the specific water use systems. This assessment should consider any pathway of the reclaimed water to reach sensitive targets, so environments at risk or workers. What I wanted to highlight here is that it's very important to characterize the source of wastewater at the beginning, considering source control to reduce the environment, and hopefully with the new rules of the Urban Wastewater Treatment Directive, it is expected to improve water quality at sources. It's suggested to define, to understand how to reduce pollutions based on regulated pollutants in applicable legislations of targets that they are within the territory, and also what this could be applicable to food and feed in agriculture irrigation. Very quickly, I will give an overview of our technical workshops that they are ongoing. That we have several topics covering. One topic is the risk assessment of the contaminants of emerging concerns in the risk management plan. This is an ongoing procedure based to the fact that many member states and stakeholders have asked to to give more indication on how to consider these contaminants. So we tried together to bring experts and stakeholder group together and see what is the ongoing research on assessing risk of contaminants of emerging concern, that also exploring methodology for selecting these contaminants to include in the list of hazard. We will have another workshop on the same topic in June. And also we are also exploring water use beyond agriculture irrigation. We have a technical workshop on industrial reuse, where we highlight that the sector in Europe, it's using it in some part of Europe is using municipal water for industrial application, especially in cooling systems and in the process production, for example, pulp and paper, and we will have a next workshop in September 2024. And also we explore humanity-related and environmental application of reclaimed water, which include irrigation of urban parks, with the example of Lisbon and Madrid, and methodologies of risk management and determination of water quality for park irrigation by, for example, ISO standards. We also learn about the possibility to use reclaimed water for other uses like snow production in the Baltic Sea region or for environmental restoration in the south of Italy. So very quickly, conclusions. The regulation is ongoing and is being implemented in the member states. The member states, the water use systems are currently drafting risk management plan. The new legislations, the Urban Wastewater Treatment Directive and the Industrial Emission Directive, will facilitate water use. There is a potential of water use beyond agricultural irrigation, especially in Western and Eastern countries. We still see many challenges that will be addressed with the working group and with the stakeholders of the member states, and JRC will support continuously the implementation of the water use with technical workshops and scientific advancement. Thank you very much, and I will reply to any question, if any.
Thank you very much,
Will
Roberta, for the presentation. If you want, you can stop sharing your screen directly so the participant could see you better. We had the questions in a Q&A. That first start with, thank you for this opportunity. Coming from the southern side of the Mediterranean Sea, my question is, has the acceptance of water's origin been addressed?
I cannot see the question, so
Yeah.
it's on public acceptance.
Yeah, exactly. And
Well,
is
yeah.
yeah.
So according to the regulation, the public acceptance should be addressed by providing transparency and communication. So the member states and within the specific water use system, they should prepare a communication campaign to inform the public about the specific water use system, and also with the transparency provision, all the data on water use will be publicly available in the reporting website.
Thank you very much. So far was the only questions. Maybe because we still have 2 minutes, I would like to allow you to, if you can say just a couple of words about this water reuse webinar that the GSC just started, because if I'm right, you already had the second one last week. I do believe they could be they are really interesting. We attended a couple of them already. And maybe if you can just do a bit of communication, let's say, for it, I think for the audience, it would be, yeah.
Yes, sure. Yes, thank you for this possibility. So the workshops now they have the main objective to gather experts together, but also stakeholders and practitioners, everybody that is involved in water use, first to exchange best practices. So the initial goal was to this was started, the initial goal was to draft guidelines on the risk management plan, and it was the set of this format of workshops was very useful because it could really be a moment of exchanging challenges and share expertise between the participants on specific topics. So it was very useful for drafting then the final guidelines. Um, then after with the implementation of the regulation, we want to use the workshops as a way to keep discussing the challenges and the barriers and keep suggesting what we could do to improve and to support the implementation of the water use regulation. So in the specific one main question was how to address contaminants of emerging concern, and we try to promote this discussion, and we had this in the last workshop, and same topic will be for the workshop in June, but also exploring best practices in beyond agriculture irrigation. This is also for also for public perception. We want to see if the fear, if some fears of around reusing water are a perception or are real, are due to real conditions, and we are sharing data and most updated uh, research to yeah, around water use.
Perfect. Thank you very much. So in the meantime, we collected 2, 3 more questions. So we'll go with one. And if your question is not answered now, we will take it at the end during the roundtable. So please leave it into the Q&A function. So we had one coming and says that in all we use regulation, is there a similar differentiation between operational monitoring of water quality and compliance testing as in a European Drinking Water Directive?
I'm sorry I
Wait,
didn't get
I will
the
I will send it to
question.
you directly per chat as well,
Yes,
so you
because I
can just
cannot
read
see
it.
it.
Yeah, yeah. Up here you have it. So I'm just reading it out loud. In the same times, in all we use regulation is a similar differentiation between operational monitoring of water quality and compliance testing as in a European Drinking Water Directive.
Um, it's only one regulation, and there is not differentiation between operational monitoring. I mean, there are minimum requirements, and it's suggested to follow some standards for sampling and analysis. But for compliance testing, we are also working on a follow-up um, guidance, mainly for validation monitoring. If I get your question.
Perfect, thank you. Then I will take one more. They say that on a slide that you shows, I did not see heavy metal contamination in the monitoring parameter. Is that correct?
If it is not
It's
clear from the
yeah, it's heavy metal contamination. They did not see it into the monitoring parameter. Is there any reason for it?
well, the regulation, the water use regulation sets some minimum requirements. They are mainly they are E. coli, TSS, BOD, and Legionella and intestinal nematodes. Any other additional requirements should be based on the risk management plan. The risk management plan will identify any contaminants, pathogens, pollutants, substances that they are in the reclaimed water, and will assess those risks and will determine if some of them they should be added as additional water quality requirements and monitoring requirements. So these additional requirements will be set up in the permit, and they will be then the competent authority for that specific water use system to determine that. So it can be any contaminants.
Perfect. Thank you very much. Now I take just one last one that should be just 1 or 2 was a short. Will there be regulation in place for water we use from small wastewater treatment plants, let's say between 50 and 1,000 person equivalent? That would be basically below the PE from the new Urban Wastewater Treatment Directive.
No, the regulation doesn't give a differentiation between small and big. It applies every time reclaimed water from urban wastewater treatment plant will be reused in agricultural irrigation. You have to meet minimum requirements and risk management provision.
Thank you very much, Roberta. please stay with us and for the wine table after it. Now we will move to the next presentation and to the Impulse talk. The first one will be done by Professor Jiří Vána from the University of Chemistry and Technology in Prague, Czech Republic. Jiří is a full professor of the university in Prague then, and he leads research group on wastewater treatment and reuse. He has also been active in different positions in the International Water Association and for us, the European Water Association. Jiří's presentation will be on reclaimed water for greening of urban areas. Jiří, please, the floor is yours. You have 10 minutes. You can start sharing your screen.
Okay, Artur Šerkov, thank you for the introduction. Good morning to everyone. In next 10 minutes, I would like to tell you something about the project which we studied in Prague as a part of the International European Horizon project, which was named Wider Uptake of Water Smart Solutions. And the Prague part was aimed at the demonstration, safe demonstration of reclaimed water for the irrigation of urban greenery. In the project, 2 universities from Prague were involved, our University of Chemistry and Technology and the Czech Technical University, and also Prague Water Management Company and Prague company supplying water in the city. The objectives of the study which we did in Prague were first to demonstrate the feasibility of using the reclaimed water in urban water management after proper post-treatment. And in our experiments, we tried to reach the quality which is required by the European regulation, which was just introduced to you by Roberta. We performed irrigation tests, which the purpose of the test was to demonstrate that there will be no negative effect of the reclaimed water on irrigated plants, soil, and the groundwater. And we used these experiments also for studying the market potential of the reclaimed water in the condition of the Czech Republic, and especially to support the new legislation, or at least the attempt to introduce the new legislation on water use in the Czech Republic. As you can see, Prague is one of the top 10 cities around the globe concerning the amount of urban greenery related to one person. And on the photographs of the left-hand side, you can see the green valley of the Vltava River and the island, which is hosting the wastewater treatment plant of the Prague, which was put in the operation a few years ago, with a very modern concept of the plant, which was built in the underground, and it's covered by a green roof. Prague is surrounded by several golf courses, which the golf is becoming very popular sport here. And because of lack of water, all these new golf courses must be supplied by the reclaimed water. What is the problem with the water in the Czech Republic? This is the specific hydrological situation of the Czech Republic when the country is located on the so-called roof of the Europe, and there is no single big river flowing into the country. All our rivers originate here, and they are leaving the country, and they are draining the rainwater to our neighbors and to the continental seas. As a result, the Czech Republic has a very low renewable water resources. We have only 1,500 cubic meters per year per person, which is far less than the other European countries. Also, there is a problem with the metropolitan area of the Prague, which is supplied from 3 sources, but the major source will be probably facing the problems with the capacity in the future because of steadily increasing temperature in the country, the temperature increase, and the temperature increase is accompanied by increased evaporation and evapotransportation of water. So the city of Prague supplies also the so-called metropolitan area, and within next 20, 30 years, this area, in this area, we will have about 1.6-8 million people, and the resources will be probably not enough. That's why we also started to deal with the water reclamation in Prague. And within our project, we wanted to demonstrate the safe use of reclaimed water from the effluent from the local wastewater treatment plant after certain post-treatment for the irrigation of typical municipal greenery. We use the river water for comparison, and we compare this river water with the tertiary treated effluent from the plant effluent after disinfection, and the plant after effluent after ultrafiltration and UV disinfection. We have been performing 24 months of controlled irrigations, and we tested the quality of not only of the water, but also plant biomass, soil metrics, and the drainage water, just to study the contamination of the possible contamination of groundwater. And we used these 2 years for a very intense presentation of the experiments and the demonstration units to politicians and also to general public. Here you can see a few snapshots of the demonstration units. They were made of plastic with the drainage bottom, which enabled us to study also the water penetrating through the layer of soil. The units were equipped with the sprinklers distributing the irrigation water. And as you can see, the units were divided into 3 compartments, and each compartment was hosting specific representatives of the municipal greenery, the grass, flowers, and bushes. The demonstration units were covered by polycarbonate roofs to avoid any interference with the atmospheric precipitations, and at the same time to enable the daylight to permit to the plants. So for those 2 years, the plants have been irrigated only with the irrigation water with no atmospheric precipitations. Here you can see also the unit which were used for the disinfection and ultrafiltration of the effluent from Prague wastewater treatment plant. We can say after 24 months of irrigation experiments that we steadily were able to achieve the Class A according to the chemical quality, the Class A according to the regulation of the European Union. There was a question for the previous presentation about the heavy metals. So during our 2 years of experiments, we didn't observe any big difference in trace elements content in the irrigation water in comparison with the river water. We measured about 60 different types of micropollutants, like the pharmaceuticals and hormones. And we didn't observe any accumulation in the plant biomass. Concerning the microbiologic quality, the ultrafiltration plus UV disinfection safely was achieving the class B according to the regulation. We were also interested to know whether there could be some salinization of the soil after 2 years of irrigation without any diluting effect of the precipitations. And we can conclude that the wastewater which was used, the effluent, didn't harm the plants and the soil microbiome. And the salinity of effluent was slightly higher than the salinity of the river water, but it was not accumulated in the soil. And thanks to the many visits to the demonstration units, and thanks many presentations in the newspapers and on TV, we quite popularized among the Czech population the idea of using reclaimed water for the irrigation in the cities. So with this, I can conclude my brief report about the project. I would like just to draw your attention to the nice flowers which we were able to cultivate during the irrigation with the effluent, and the effluent didn't cause any harms to any insects. On the other side, the bees especially liked our flowers, as you can see. Thank you very much for your attention, and I'm ready to talk with you in the Q&A section of the workshop.
Thank you very much, Jerry, for sharing your experience with 2 years of implementation of the water reuse regulation and sharing with you the good practice from the city of Prague. Yeah, so dear participant, do not forget to use the box for Q&A and the chat at the bottom. And as Jerry said, we will just now move to the next presenter. That will be, sorry, I have to open the wrong file. Thank you very much, Jerry. So now the next presentation will be done by Max Zimmermann from the Research of Drinking Water and Water Reuse by RWTH University in Germany. Max, you have been a visiting researcher at the University of South Australia on water and also work for a water supply company in Adelaide. You are now a research assistant under Professor Dr. Thomas Wingent at the Institute of Environmental Engineering of the RWTH University in Germany with a research focus advanced treatment for water reuse and micropollutant removal membrane hybrid processes. And you will talk today about the FlexTreat project, flexible and reliable concept for sustainable water reuse in agriculture. It's a pleasure to have you with us. Max, the floor is yours.
Well, thank you very much for the kind introduction, Arthur, and hello everyone across Europe. As said, I would like to introduce to you the ministry-funded project FlexTreat to you with the name Flexible and Reliable Concepts for Sustainable Water Reuse in Agriculture, and thereby give you a little insight on the current state of the theme water reuse in Germany right now. Therefore, we're going to look at a bit of context first, because water reuse is not very far spread in Germany yet, because drought in Germany is a very recent issue. What you can see on the left here is the drought intensity of the ground in 0 to 2 meters depth over the last 51 years. And you can see there has been a few drought years every now and then, but only recently, since about 5 years, we have following years with drought conditions in some areas of the country. And probably most of you know that these drought conditions can be directly converted into the so-called utilizable field capacity, which means that in the lighter colored areas here, the crop capacity of the fields decreases to below 50% of what they used to have as capacity in these fields. Slowly rising awareness for water scarcity issues in these areas, and therefore also slowly increasing the demand for water reuse in Germany. And another thing that's very relevant for the following, before we look into the project, is the current legal situation in the country. As we heard from Roberta as well, you're all aware of the EU Ordinance 2020-741 that is active and must be followed since June 2023, also in Germany. And currently, a process of putting this water reuse ordinance into national law is on its way, which is still ongoing at the moment. And it is expected to become substantially stricter in some aspects, probably proposing a challenge to introducing and implementing more water reuse projects in Germany. This national law will then be based on a technical guideline that is spread into 3 different parts: the basics, the requirements, mostly the technical requirements, and implementation. And the Flex Street project that I'm going to present to you soon is mostly set in the context of these technical requirements. We're going to see that soon. There is one more development, though, that's also very relevant, and that is the EU Urban Wastewater Treatment Directive. I think most of you will have heard that just recently, on the 10th of April, the proposal has been adopted by the Parliament. So this will introduce the requirement for micropollutant removal to bigger wastewater treatment plants. And anticipating these 2 developments, a strict water reuse regulation and the micropollutant removal, the proposal for Flex Street was written. So what we try to do in this project is find synergies between micropollutant removal and water reuse disinfection technologies. The project is spread into 4 work packages, which some of them we're going to look at now, just very briefly, starting with the technologies. As I said, we're mostly looking at synergies here. So we chose 4 different treatment trains in this project that are mostly piloted in half technical scale, except for one site that's already implemented in large scale. This is an ozonation followed by filtration and UV disinfection in Brunswick, Germany, one of the few places where agricultural irrigation is already being done in the country. A second technology train in Rheinbach, Germany, consists of a constructed wetland with additives of granular activated carbon for micropollutant removal, followed by disinfection in form of conventional UV or UV LED to compare and do research on the comparison. Another option that we're looking at is powdered activated carbon dosing in front of ultrafiltration membranes, followed by UV disinfection in the effluent. This part actually being what my PhD is going to be based on. And one last option, a bit more, let's say low tech, but a very clever idea, is the combination of constructed wetlands with so-called online electrochlorination, which has the opportunity to reduce the chlorine dose by quite a bit. However, chlorination in Germany is seen as very critical and will probably not find its way into application anytime soon. So what do I mean when I say we're looking for synergies between these technologies? I brought one example of this, looking at the ozonation treatment train. So what we see here is the E. coli concentration at the different stages of this treatment train. And we can see a reduction in the conventional activated sludge process, and then a big reduction in the ozonation stage. What we have to say here is that our ozonation stage is not aiming at disinfection, not complete disinfection of the water, but the ozonation stage is run in a way that's economic for 80% micropollutant removal. So while removing micropollutants, you also partly disinfect the water, and then only this last bit, 2 log stages, must be removed by UV treatment. And now, of course, this is kind of an obvious synergy that the oxidation already reduces the E. coli concentration. But what you cannot see here, but is more of a hidden synergy, is that ozonation also improves the UV transmission of the water quite a bit by 10 to 20 percentage points. And that will allow for a much more economic UV treatment afterwards. Unfortunately, I don't have any cost saving numbers yet. We are working on that currently. Next, I would like to talk about the risk management work package, because this really is the heart of the project. So it divides into 2 major parts: the microbiological risk assessment and the chemical risk assessment. On the chemical side, we're looking into the entire nexus of irrigation water, soil, and also contaminants in the plants. While on the microbiological side, we have a very fast spread portfolio of bacteria, viruses, spores. We're looking at antibiotic resistances, but also Legionella and the regrowth potential of the water that we create after our treatment. If you're interested in more detail on this, then feel free to contact me afterwards. Then there is a dedicated work package on the utilization of the project results. And as we saw during the project, this is very, very important because, as I said, there's very little experience with water reuse in irrigation in Germany. And what we did in the project was acceptance polls and stakeholder dialogues. And they mostly show a very streamlined outcome, which is that we really need to work on our communication with farmers, with water companies, to give more understanding to the needs, the risks, the opportunities connected to water reuse. We can see here, legal requirements are not quite clear. Health concerns are there. The infrastructure and cost question is not yet answered in Germany. And also, some people believe there is insufficient information about the opportunities and risks involved. So ending on this, I would like every one of you to use this as a reminder that we can still work on this communication, which we are doing right now, but we also need to carry this out to the agricultural community and other stakeholders. That's it already from my side. I would like to thank you for your attention. And if you want to know anything more on this project, feel free to visit our website, contact me directly, or ask to meet up at IFAD. I'll also be there for the first 3 days.
Perfect. Thank you very much, Max, for the very interesting presentation. And we will definitively meet you at IFAD during the first 3 days. Again, do not forget to use the Q&A or the chat function to ask your question for Max. Max will be available after it for the one table. And now we will move to the next presenters. The next presentation will be done by Melina Rocamante, who has a degree and master in chemical engineering and a PhD in biotechnologies and industrial bioprocess applied to agri, food, and environment. You are currently part of the Innovation and Technology Department of Aqualia, where you worked as a researcher in the Life Phoenix project. And today's presentation will be on water reuse and its impacts on the Food-Water-Energy Nexus. Melina, you can share your screen and the floor is yours. Perfect.
Okay, thank you for your introduction, Arthur. Okay, my presentation is about water reuse and its impact on the Food-Water-Energy Nexus. The presentation will be divided into the following content, and I will start with a little introduction. According to the latest European assessment, water treatment represents 0.8% of electricity consumption. The current wastewater treatment plants based on the active sludge system have become obsolete. The change of concept between a wastewater treatment plant and a biofactory is feasible thanks to the application of new systems and technologies capable of reducing the electricity consumption of the facilities, generating energy and recover products such as treated water and nutrients. Water reuse in Europe is still limited and mainly implemented in countries with severe water scarcity. Reusing treated effluent from wastewater treatment plants for agricultural irrigation has significant potential to reduce pressure on stressed freshwater sources. Based on these points, Aqualia and its partners have developed several projects that include different solutions to the above points. These projects are Life Ulysses project, Life Zero Wastewater, and Life Phoenix project. In the next few slides, I will describe these projects. Okay, Life Ulysses project, the main goal of this project is to upgrade conventional wastewater treatment plants by different innovative technologies that produce useful resources from wastewater, such as automated biofuel, biofertilizer, and water for reuse. And the project aims to reduce energy consumption and minimize the carbon footprint of wastewater treatment plants, increasing their efficiency, but the integration of different technologies in each of their lines, water, gas, sludge. A demonstration plan that integrate these different technologies has been implemented in Elbow Bar wastewater treatment plant in Almeria, in Spain. And these technologies are a novel anaerobic pretreatment technologies based on UASB reactors called PUSH, is able to produce biogas from raw wastewater and at the same time reducing its contaminants load with no need of oxygen or heating. A novel biogas upgrading process patented by Aqualia called Abad Bioenergy purifies and enriches this gas to generate biomethane, a biofuel that meets European standards. Using wastewater as absorption media, it offers a low-cost upgrading technology that can produce a competitive fuel for CNG vehicles. And this biofuel is tested in real driving tests during the project. A novel solar-based tertiary treatment treats the secondary effluent of the wastewater treatment plant to produce drinkable water. Thanks to solar radiation and the action of iron salts, pathogens from water are killed and microcontaminants are degraded. Once the wastewater is disinfected, it can be safely reused for agricultural purposes. Traditionally, sweet sludge has been managed in wastewater treatment plant as a waste. In Life Ulysses is testing two demonstration plants that will change this paradigm, recovering valuable resource from sludge. First, a sludge hydrolysis plant treats the solid fraction of the sludge generated in the wastewater treatment plant. In this reactor, enzymes are added in order to break biosolids into bioavailable compounds that enhance crop growth. A solid biofertilizer rich in nitrogen and phosphorus is then obtained. As well, membrane-based precipitation plants recover nutrients from the centrate, the liquid fraction of the sludge. A high-quality fertilizer called struvite is obtained in this project. In this process, agronomic performance of this biofertilizer and reclaimed water from solar tertiary treatment are applied all together in a field crop fertigation test. By the implementation of these different technologies, Life Ulysses aims to turn conventional wastewater treatment plant into a biorefinery. With the same purpose, the Life Zero Waste water project is currently being developed in the Elbow Bar wastewater treatment plant. This project studies the feasibility of a joint treatment system for wastewater and the organic fraction of urban solid waste has an innovative solution with a positive energy balance and economically profitable in population of less than 50,000 inhabitants equivalent. This project consists of anaerobic and autotrophic bioprocesses to transform the treatment plant into a research generating biofactory with a positive energy balance. Through the development of the project, it is mainly provide a solution to the management of the organic fraction of municipal solids waste, which in turn contributes to improve the novel wastewater treatment process, avoid the loss of water, energy, and other resources present in wastewater treatments through biogas production, water recovery, waste reduction, and nutrient recovery where current solutions are not efficient. Promote a new process from the treatment of wastewater that allows obtaining reused water with different qualities depending on the legal requirements and the needs of the end users. Demonstrated the viability of anaerobic and autotrophic bioprocesses and reduce the discharge of pathogens in the effluent of the wastewater treatment system through advanced monitoring of treated water. Okay, as you know, water stress has become a problem affecting millions of people worldwide, including more than 100 million people in Europe. The main objective of the Life Phoenix project is to demonstrate the use of a novel, modular, and flexible solution to produce reclaimed water for agricultural irrigation. The combination of these technologies will produce a high-quality effluent that can meet the new European regulation while addressing other contaminants not yet included in the regulations, such as contaminant of emerging concern and microplastic. They consist of a flexible pilot plant with innovative state-of-the-art technologies. These flexible pilot plants will be validated for large, medium, and small population. Different technologies and location are available depending on the type of community target. This video show the installation of the Life Phoenix project at the El Toyo wastewater treatment plant in Almería. In the case of the flexible pilot plant, for a large medium population consists in 4 units. A physicochemical pretreatment unit, Clarifast and DAFAST, biofiltration unit with Puracer, Puravac, and Dix filter, ultrafiltration unit, and disinfection oxidation unit. All of this technology can be used independently or in combination. Pretreatment for a small population consists of a 3,000 square meter microalgae bioreactor, followed by dissolved air flotation, flotation with separate microalgae from a clarified effluent. This effluent feeds wetland for treatment to nitrify and reduce turbidity, total suspended solids, organic matter, and pathogens. It also feeds the treatment carried out by O-Partner with a solar and UV-LED photophantom pilot plant here, and a zeolite nutrient recovery system and a UV-LED disinfection system. Okay, finally, I invite you to visit our website and social networks. All news and activities will be published there. Thank you for your attention.
Thank you very much, Melina, for the presentation. So again, and for the last time, please use either the chat or the Q&A function to share your questions with the participants. I will kindly ask all presenters to switch on their camera as we'll move to the roundtable Q&A part of today's event. And I will take it, and I think we had 1 or 2, Jerry, for you. I will try to combine them into a 3. And yeah, everyone, thanks all of you for the really nice presentation. And Jerry, for you, there were a question if you had added any fertilizer to the plant during the 2 years, if you also had any, or if you notice or measure any difference in the quantity or biomass of crops irrigated with a treated wastewater as compared with a conventional irrigation. And also if you conducted some tests to see if the flowers, vegetable or fruit trees that were potentially irrigated were still eatable. Thank you, Jerry.
Mm-hmm. Okay, so thank you for the questions. We didn't add any fertilizers during the irrigation period of 2 years. First of all, because part of the necessary fertilizers were present in the soil, which we used for filling the irrigation boxes. And secondly, even though we were using the tertiary treated effluent, there were still some residual concentration of ammonia, nitrate, and phosphorus, and that was probably enough for the fertilizing effect of the water. We even didn't add any other chemicals because the chemicals could interfere with the analytical procedure when we were measuring the micropollutants like the pharmaceuticals. Concerning the quantity of the biomass, we measured, let's see, quantitatively only the production of the grass, because the grass was regularly cut during the experiments, not the flowers, not the bushes. But each box was equipped with a camera which was registering the time-lapse images. And we collected these images, and we can show these movies based from these images. And we didn't observe any significant difference in the speed of the growth and also in the extent of the produced biomass, at least optically. Concerning the question of the
had a question if it was eatable, if you had conducted tests on either
we did another set of experiments in the cooperation with the Czech Czech Agriculture University in the greenhouses of the university, where we cultivated some typical vegetables like the carrots, salads, etc. And we measured the intensity of the production of the leaves and also the quality of the products. So concerning the chemical quality, we didn't observe any difference between the river water and the effluents which were used. We also tried to establish some root of the antibiotic resistance genes from the wastewater to the plants. And especially in a case of the tomatoes, we found that some of these genes could be found in on the cover of the products of the fruits. So maybe after careful washing, it will be not so dangerous concerning the distribution of the antibiotic resistance genes. And concerning some online monitoring, we measured also continuously the humidity of the air and humidity of the soil. And from this, we were able to calculate the exact dosage of irrigation water. So in fact, in most of the cases of the sampling, we didn't produce any groundwater contamination because all the irrigation water was consumed by the plants. And most of the sampling of the chemical and biological sampling were done on the conventional samples transferred to the laboratory and measuring in the laboratory.
Perfect. Thank you very much, Thierry. Max, I think the next question will be for you as well. We had mainly two questions. The first one was to ask you which technology are you using to test microbial bacterial load of the samples that you're taking? Are you only using any online monitoring techniques or only culture-based testing? And the second one is a bit related to this. I think they wanted to hear a bit more about the digitalization topics under your project.
Mm-hmm. So on the first question, for everything relating the EU ordinance, we used culture-based methods. For the research part, we also, concerning the regrowth of bacteria, we used flow cytometry, but this is non-specific. So we can differentiate between living or dead cells, but we cannot say what bacteria that is. There is also a little part on trying to make qPCR into a mobile applicable device. However, that did not include all the measurements we did in the lab. I spared out the digitalization part because I'm no expert in it. The digitalization questions we had were mostly done with the ozonation plant, and it is Xylem Aquatune who did this part of the project. They established a digital twin and use AI to predict the water quality. And we're also then going to look at potential surrogate parameters where we can estimate a safe water reuse. Arthur, if I may, there was one more question in the other chat that didn't get
in the
through.
chat, exactly. I wanted to ask you as well. So just for everyone, so it was a question for Max to ask if you have evaluated the power consumption by technology, as ozone is quite an energy-intensive process.
Mm-hmm. So two things on this. Yes, we are going to do an LCA and cost assessment within the project, but that's still ongoing as we just finished the piloting. And just to be sure, you would only use ozonation if you want to remove also micropollutants. You wouldn't use ozone if you solely want to disinfect the water. That would be too expensive indeed.
Perfect. Thank you very much. And I don't know, I think Melina, we are facing some issues. We also had a question for you in terms of what measure has been implemented to reduce the risk of fluctuation in wastewater effluent entering wastewater treatment plants and ensuring the consistent quality and quantity quantity for reuse. And I just wanted to say also, Max and Melina, as a Max, what you just mentioned about the energy cost, and Melina, when you talk about the Live Zero wastewater part and to try to be energy neutral for your wastewater plant below 15,000 PE, I do believe it would be of high relevancy with the new energy neutrality criteria and the urban wastewater treatment directive recast. That's problematic that we are all at least getting into it and learning a bit more about the energy cost and all of it. So I think Melina, if you could maybe the first questions, or if you have too much problems with the connection, then we can take someone else.
Sorry.
So was someone just asking if you what measure have
can
been
you hear me? I can't hear you very well.
Okay. Yeah, it was a question on what measures have been implemented to reduce the risk of fluctuation. Yeah.
Okay. I thought, okay, the proposed technologies in the different projects help to improve the quality of the effluent from the wastewater treatment plant. The objective of all projects is improve the quality for reuse this water.
Okay, thank you very much. So I think then I will take one question for Jiri and then come to the other one, because the last one on the Q&A, I didn't have time to read it. So Jiri, we had a question that where you had mentioned in during your presentation that you observe an increased salinity, but it's did not accumulate it in the soil. Does this depend on the type of crop that you use, that they're assimilating all sorts, or that we could see an effect in a longer time period? Thank you.
We tested the salinity in all three compartments. That means the soil which was used for planting the grass, flowers, and trees and bushes. And the salinity was more or less the same in all these compartments. So I do not see that there were some influence of the plant types. The accumulation which we measured was, in fact, the soil salinity from the beginning of the experiments dropped because there were some salts present in the soil we used for the irrigation. But after 2 years of the experiments, it returned just to the level which the salinity was at the beginning of the experiments. And I would like to stress the fact that there was no any effect of the dilution by the precipitation. The experiments were covered even in winter, so there was no interference with snowfall, etc. So that was just purely affected by the water.
Perfect. Thank you very much, Jiri. Yeah, Max, do you want to
Arthur,
add something?
Yeah, I would like to add something because I might
Please.
add some value here. We have a little work package on salt management as well in irrigation, and I can post a link in the chat. There's a really nice tool from an Israeli university where you can check for your specific location. You still need to do the research on the parameters, but you can put them into the tool on whether this might be relevant at your site. So it depends on the soil composition, the crop you're trying to grow, and the water quality, whether this is a question or not. I posted the link in the chat. Maybe people can use it.
Yeah, thank you very much. And then one of the last question on the Q&A, we had one, I think, Roberta, also just for you in terms of the scope of the EU water reuse regulation. And someone was wondering if it covers so landscape irrigation from reclaimed water.
Yes, I saw the question in the chat. So the regulation as it is applies to use of reclaimed water for agricultural irrigation, but the Annex 1 says that member states may consider to use reclaimed water under this condition for additional uses, including industrial reuse and amenity-related reuse, which is irrigation of urban parks, and environmental reuse, including environmental restoration. So that's we had this a workshop discussing about the uses of under this perspective.
Thank you very much, Roberta. Then we had the second question, I think, or from the same person, I think was for you, Jiri, on the wider uptake project. It was to ask you, you say that after treatment plant and ultrafiltration and UV, the reclaimed water was type B due to microbiological parameters, and which particular parameter? Was there any trial with chlorination or other disinfection? Thank you very much.
Thank you for the question. So we, apart from the parameters which are required by the regulation, we measured also other bacterial indicators, and I think the problem was that we were not able to guarantee the stable level of E. coli by the combination of UV and ultrafiltration. And we didn't use the chlorination in our experiments because the water which was prepared on site was immediately used for the irrigation. But we are aware that if we are doing this in some larger scale, we will have to store the produced reclaimed water before the irrigation. And in such a case, in the storage tanks and in the distribution pipes, we should add chlorine definitely, because the UV light is working just at the moment and is not protecting this water later on. So we were not very much concerned about the class B, because we said, okay, if we are using this process in the full scale, we will chlorinate anyway, and the chlorination will definitely guarantee the class A. We also measured Legionella, because the water in the parks is usually distributed by sprinklers. So we were interested to know whether there is some danger from Legionella, because it's dangerous when it is inspired. And we have to say that even the effluent from the plant during those 2 years in any sample didn't contain Legionella. So that was not the problem of the Prague effluent.
Perfect. Thank you very much, Jerry. And yes, Roberta, you're right. I overlooked one question. That was, do regulation and minimal requirement change from a country from another? So please, you.
Yes, so well, the regulation it's a legal it's a binding legislative act, and it applies in its entire form to all the member states. So I would like to highlight that the member states, they cannot add stricter or additional requirements to the regulations. What it happens under the requirements of the regulation, there are minimum requirements, of course, but additional requirements should be based on the on the outcomes of the risk management plan. Indeed, member states, not member state, but competent authority that will at the end approve the risk management plan of the water use system and set up additional requirements in the permit, may require that some contaminants may be considered, but this should be under risk assessment. And of course, member states may release guidelines that will guide the member state national guidelines of which parameters to consider. So I wanted to highlight this also because, Max, you say that the Germany requirements might be stricter, and I wanted to clarify that that stricter requirements may be added maybe in territories on a overall risk assessment or within a river basin plan which has specific pressure and will require from the member state to say, okay, additional to this, we'll have additional requirements to protect this drinking water source, for example. So, but it applies entirely in all the member states, as differences will be a directive that need to be adapted to the national context.
Perfect. Thank you very much, Roberta, for this clarification. and for the answers. And I will just quickly share my screen again. I think you can now all see it. I would like to thank everyone for today's presentation and taking part in our webinar today. As previously mentioned, and the PowerPoint and presentation will be shared with everyone. There will be a recording on today's webinar on our YouTube channel. As we mentioned, IFAT, also Max will be there. From the EWS side will be there as well. So this is an overview that you will get. And as you can see on Monday afternoon, we have a session on a blue stage on water reuse, chance or meander, with the moderation from Nora Pankow from the Bundeswehr University Munich. I think she was also joining us today. We'll have Professor Dreves, chairperson of Urban Water System Engineering at the Technical University of Munich, Professor Uli Petzer from the LIPA-Verband and DWA president, and also Mr. Ayati Yarkadas, the president from Europe's Xylem. So this will be the second part of today's event. So feel free to join us. It's free of charge. As we mentioned, we also have other webinars. We have one next week already, free webinar with new paths of qualification and recruitment in the water sectors that will also be discussed during IFAT. And we also do our yearly introduction course to the EU water policy and legislation. You will find more information on the EWA website. You have our social media made in all of our channel, our newsletter as well, where you can register. And today, when you finish, you will directly get a survey for feedback. So please, it takes just 2 minutes. It's there to help us to improve ourselves and to get better. So once again, thank you very much for all the participants. If you have any questions, just send it to us. And it has been a great pleasure to organize it and to have it with us today. So once again, thank you very much. Bye.
Bye.
Thank you very much and bye.
You go.
Goodbye. Thank you.